Hello and welcome. My name is Bernd Schubert, and I would like to show you in this hands-on training HOL-1225 how we can make the central instances of the application server high available with our Pacemaker solution. First of all, I would like to explain you the new SAP enqueue replication mechanism. Then I would like to say some words about the lab infrastructure which we are using for this training, and then we will start with the hands-on training. First of all, the SAP has improved the enqueue server, standalone enqueue server 2. And the mechanism has changed. As you can see on the left side, the ASCS has an enqueue log table, which is replicated to the ERS. This is the same as in the past. But now the ASCS is able to retrieve the logs over the network. In the past, the ASCS must move to the ERS host because the log table was only able to copy over a shared memory segment. And this procedure has now improved, and the ASCS can retrieve the logs over the network. And when the enqueue log table is copied from the ERS back to the ASCS, you can see it on the third section here. The replication is changed back from the ASCS to the ERS. So only during the recovery process, the replication, or more or less a copy process from the ERS going to the ASCS. To achieve the certification, the SAP HA certification for S/4HANA, we have this SUSECON cluster connector in between. So the SUSECON cluster connector is a communication layer between the operating system and our Pacemaker component and the SAP control framework. The SUSECON cluster connector gives the possibility to communicate or to let the SAP substart framework communicate with our Pacemaker. So in summary, the ASCS local restart is now allowed by an error, means failure of the ASCS, and also by admin purposes like maintenance procedures. What will we do in this hands-on training? We will configure the SAP Management Console. We will work with the Pacemaker. We integrate the ASCS and ERS instance in a Pacemaker and set up this high availability scenario. And then we will verify if the cluster is working as expected and meets the SAP certification requirements. And by the end of this hands-on training, we will also do some SAP maintenance tasks. And I would like to show you what happens if we don't have the SUSECON cluster connector integration in such a scenario available. What we will do, we will use the SUSE tools like the cluster console, the HOG console, it's a graphical interface. We will use the command line tools like CRM or other SUSE tools for monitor the processes and configure the cluster, and also see the SAP instance situations. We will also use SAP tools like the SAP Management Console, and on the terminal we will use the SAP subcontrol command. And yeah, what we are using for this hands-on training is a 3-node cluster. This 3-node cluster is a diskless SPD cluster based on SUSE Linux Enterprise Server for SAP application, because our SUSE cluster connector is only available in this product. We will have the clusters already set up, and it's an empty cluster, more or less empty. So only one resource is already configured, but I will come to this later on. So the HOG console is already running and listening on an IP address, so we can connect to that. From the SAP point, we are using an S/4HANA Central Services 1909 which is already installed. And we have a fourth host. On this fourth host, we will use this fourth node as an admin server. And on this admin server, we have installed the SAP Management Console, and we will also use this host to connect to the cluster nodes and configure them. So this admin host is more or less a jump station for us, or an operational host. That's a picture how our cluster looks like, where we will implement the central services. So we have 3 nodes, they are empty. And when we finish, we will have an ASCS and ERS running somewhere in this cluster. So the cluster will decide where this ASCS and ERS will be started, if he has the chance to do this. If we already start the ASCS and ERS, the cluster will accept this situation and will leave the instances running where they are. So we have a virtual IP address for each SAP instance, one for the ERS, one for the ASCS, and we have a spare node. So if something happens, to see that the cluster is able to move a resource from one host to the other host. Okay, that's our general disclaimer. Let's start with the hands-on. Hello and welcome to the practical part of HOL-1225. We will show you here what you have to do to make an S/4HANA central instances high available. This is our guide, which we will using, and this is an extraction of our SUSE best practice, what we have for S/4HANA and for NetWeaver. First of all, we will get familiar with the infrastructure, then we will check the installed SAP system, and then we will integrate the SAP system in the SAP Management Console. After that, we will integrate the SAP system into an already installed cluster, and then we will do some cluster tests. And in addition, we would like to show you what happens if we don't use the SAP-SUSE cluster connector. So to see the differences between the certified solution and not certified solution. Okay, let's go through. First of all, we would like to get familiar with the infrastructure what we have. I'm already logged into an additional node which is called admin. This admin node is outside of the cluster, and we will use this for all the operation stuffs what we have to do with our 3-node cluster. First of all, I will log into the management console from HOG, from the cluster. I'm using the credentials HA cluster and the password for him. I'm using here a global IP address, which is already configured in the cluster. This gives me the possibility to log in every time to the same IP address. It doesn't matter where this IP address is running in the cluster, because this IP address is configured as a resource in the cluster, and the cluster will take care for that and start this IP address. So what we have here, we have monitoring, troubleshooting, and configuration. Under monitoring, we see already the status information, and we see we have one IP address, one resource configured. The resource is running on the cluster node SUSE1. So we have 3 nodes in our cluster. It's SUSE1, 2, and 3. And the 4th node is admin, which is outside of the cluster. Okay, so everything is operational and working. We have a different view here on the dashboard. If we go to dashboard, and I have to increase a little bit the window, we can see also the information, how many nodes we have in the cluster, and the resource, and the symbol signals the resource admin IP is started on SUSE1. And if you open this legend pull-down menu, you see the signs and the colors, what they are standing for. We have this troubleshooting section here. And this troubleshooting section is quite nice. It's a graphical interface which helps you to analyze cluster situations and behaviors. And you can also generate an HDB report here. If you have a cluster issue and open a call by SUSE, the first thing what the support guys are requesting is an HDB report, and you can generate such a report here. Upload, download, delete, and whatever is necessary can also done over this graphic interface. With the upload, you can upload an HDB report to this HOL console here, and can then later on, if you open this, look in this HDB report and do some investigations and analyzes what happens in this HDB report. We also have a configuration button here. With this configuration settings, you can modify your cluster. We have also wizards here, and these wizards are the wizards which we are providing, helps you to set up your cluster for certain scenarios. But this is not part of our session today. We will do our maintenance or our configurations on the console. Okay, so let me switch this a little bit back. So, okay, let's go back to the documentation, what we have to do. Okay, log into the admin server, we already did. We have opened the Firefox and connect to the HOL console. We have seen the monitoring entry, the cluster resources, and the cluster node tab. Okay, yeah, we have shown the monitoring, we opened the legend. Okay, let's do this from the console again. First of all, we log into one of the cluster nodes, and then we run CRM status and see what we can see there. SUSE 3 CRM status. Okay, so on the console we have the same information there. So we see here SUSE 2 is current DC. Current DC means it's a designated coordinator, and the designated coordinator is marked by this HOL symbol, and we can see this here on the HOL console too. What we see here is we have 3 nodes in our cluster, and we have 1 resource, and 3 nodes again. All of them are online. Everything looks fine. And we have a resource which is called admin IP, and it started on SUSE1. So the information what we can get from the console are equal to the web console. That's great. Okay, next thing, CRM corosync status and CRM cluster status. Okay, CRM corosync status. What we have here, we are on local node 3, local node ID 3, SUSE 3, okay, that matches. We have 3 nodes in our cluster, and we have a quorum, so that means the cluster is operational. He needs at least 2 nodes to have the quorum, otherwise this a node will get fenced or stun of himself if he don't have this quorum equal or higher than 2. As you can see, we don't have a stoneth resource configured in our cluster. We are using here the diskless SPD functionality. That is a function what we can use with more than 2 nodes. and it's based on watchdog and this quorum settings here. Okay. Next command or CRM cluster status. CRM cluster status. And what we can see there, the cluster name, we have the heartbeat, it's running, Pacemaker is running, and this is the ID of the node in the heartbeat communication layer. And we have one communication layer for the cluster heartbeat, and we don't have any errors there. Okay. Next command, CRM cluster health. CRM cluster health. So this will give us a report over the cluster status. He will collect information from all nodes and store this information in a file. There we are. This is the result. First of all, no issues found. That's quite good. The report is stored in this file. If you would like to keep this safe, you have to copy it away from there. And what we can see here is the last entries from the log file. And we can see what happened there. So there are some cluster actions which happen between SUSE2 and SUSE3, what I can see over there. So maybe this was a node restart or something like that. So what we can see here is he checks all the informations, and that looks quite fine. So everything is okay. And yeah, he will do here a diff on the cluster information base. And okay, what's this? No, does not exist. No, maybe it's not never running there. And what we can see here, he's trying to collect all information, run a cluster healthy check and report status. So everything is fine. Okay, the important point is here, no issues found, and the information is stored there. So what we can do in addition, wrong key combination. So CRM cluster run and then check if the communication between all cluster nodes is working well. CRM cluster run. So first of all we do a date and then hostname. Okay, so the timestamp on all nodes are equal. That's quite good and very important. And you can see CRM cluster run to all nodes and gives us a return code here and say, okay, it's possible to go there, and then he runs the command. First of all, the date command and then the hostname command. So that's very good conditions what we have, and we can proceed. So what we have, conclusion, we have a 3-node cluster with diskless SPD, so we don't have a dedicated resource for that in the cluster which needs to be managed. It's based on watchdog and the quorum. So one resource is configured. It's our admin IP to get access to the cluster over the Hawk console. The cluster is healthy and we don't have any errors so far. Next page. Okay, now we check the SAP system, which is already prepared for us, and check if this is running. Therefore, we connect to one of the cluster nodes, SUSE1, and switch to the SID EN2 and check the status. So I'm lazy, I will copy the command here. And I like to work with multiple tabs. So I will here have my admin tab, and then I will connect to all of the cluster nodes. I will prepare this first. SUSE2. Okay. And third. So there we are. And now I can use these tabs every time for each activity what we have to do. I will switch to the SID ADM. And now I'm using the command subcontrol dash number instance number dash function get system instance list. Get system instance list is an overview over the whole infrastructure, over the whole SAP system, and we see we have a virtual host name for the ASCS and a virtual host name for the ERS. And this is important because we will later on move over these instances between different hosts, physical hosts, and therefore we need a host name which is a virtual host name which can be switched over together with the IP address from one host to the other host. So everything is up and running, and now we will check each instance separately. So therefore, system, we use the command get system process list. Get process list. And here we see we have two services running, the message server and the enqueue server. Both of them are green. And now we check the ERS. The ERS is not on this host. And we can run the command from here if we know the host name and the instance number. We don't have to switch over, but we can also walk through the second cluster node, log in as SID ADM, and run the get process list command from there. But we can see here also enqueue replication server is running on host SAP EN2 ER. Okay, next step. So, okay, verify all services are shown green. That's what we have done. And okay, it's not necessary. So here we have the explanation, what we can see there. We have the instances with the services. This is 00 is our ASCS instance and 10 is our ERS instance. Okay. Open multiple terminal windows or tabs. That's what I did. I have multiple tabs and connect to each system separately. It depends on how you like to work with that. Okay. So, conclusion. We can use subcontrol with the get system instance list to have a global overview over the SAP system, and we can use virtual host names to connect to the systems as long they are installed with a virtual host name, and all the services are green. So ASCS is green and ERS is green. Now let's integrate the SAP instance into the SAP management console. We have an icon on the desktop already prepared, and copied this sub-management console also to the admin node. So this console is running outside of the cluster on a node which is used for operational work. So I will open the management console. So I'm adjusting the window a little bit. Okay, first of all, we click here on this button New Instance, and then we have to provide the information of the SAP system. Our instance number of the ASCS is 00. Our instance host is SAP EN2 AS for ASCS. And then we can click on Finish. So be patient. This is a Java program, and sometimes it needs a little bit of time. And now he's asking for the login credentials. So we use the SID-ADM here, user and password. And then when we are logged in, all the informations are visible. So green means all services are up and running and the instance is fine. So what we have done here should see ASCS and ERS. That's what we did. Select the ASCS and open the substructure. So on the ASCS we can see here we have the process list, so which shows us the service, how long the service is running, the process ID from the Linux system. If we would have some enqueue logs, we would see here the enqueue log table. And the same is for ERS. So process list, so it shows us the process ID, the status of the service, which service it is. So in that case, enqueue replicator 2, and how long the system is running. So select process list and verify. Okay, that's what we can do. We will remember the process ID is 3595 for the ERS. And if we go back to our console, we will see here the process ID is the same. And for enqueue server and message server, we have 4511 and 4512. And let's check here. It's 4511 and 4512. So we have the same information on both sides on the console and in the SAP management console. Okay, the optional task we don't have to do because the ERS was already shown when we implement the ASCS into this SAP management console, and therefore we don't have to do this additional step. We don't have to discover the system. Conclusion, our SAP instance is now visible and integrated in the SAP management console. The process ID is the same on the management console and in the terminal window. Okay, next chapter. Now we can integrate our SAP instance EN2 in our cluster. We will do this according to our SUSE best practice with the SUSE cluster connector, and therefore we have to do some preparations. First of all, we log in now to the virtual hostname on the ASCS and we will stop the system. Therefore, I'm going back to my terminal window. I will clean up this here, and now I will do an SSH as SID-ADM, EN2-ADM, sub AS, EN2 AS. Okay. There we are. And we have here stop system will bring down or will stop the whole SAP instance, the whole SAP system, not only the instance, will bring down the whole SAP system. If I would use the stop command, it will only stop the ASCS, but I would like to stop the whole SAP system with once. And we can check if the system is down with the get process list and the get system instance list. Get process list. Okay, all services are here now gray. That means SAP instance is stopped. Now we have to check this on the other host too, where the ERS was running. And don't forget to change the instance number. Okay, it's also gray. We can use the global command, get system instance list. And we can also see here, get system instance list, we have the ERS with the instance number 10, it's gray. And we have the ASCS with the instance number 00, and it's also gray. So okay, we did the get process list and the get instance list. And now we have to stop the substrat serve process. And therefore we have to stop the service. First on the ASCS host, we will use the same command, stop service. And what happened now, if I would run a get process list or anything else, I will get such an error message. So now the communication over the web with the substrat serve process is not longer possible. So we have to do the same on the ERS host. SSH EN2 ADM at SAP EN2 ER. So the service is still running, and now we stop the substrat serve. Stop service. And now the get process list is not longer working. Perfect. So let's check what we have to do next. So we have logged into the ERS server over the virtual hostname. We have stopped the service, and we have checked that the substrat serve is not longer running by using the get process list command, and we got an error message like this one. Failed, Nikon refused, connection refused. Next step. So we can also check the status via the management console. Management console is here on the left side, and we can see the SAP system is now gray, and yeah, it's the SAP management console is not longer possible to communicate with the SAP system, and therefore we have this red sphere with a white bar. Okay. So we don't close the SAP management console. Now we will adapting the SAP profile and implementing the changes what we need to let the SAP system working together with our pacemaker. Therefore, we have to change the profile for the ASCS and ERS, and we will do this on one of the cluster nodes and using the VI. So I'm going back as root, and to make it right, so ACS, the IP address is still running. I have only stopped the SAP service, so the IP address for the virtual hostname is still active. And now I can modify the profile. The profile is in a shared on a shared storage under this profile, and then we have the SAP SID, the service name, so the instance name, it's ASCS with the instance number, and the virtual host name. So what we have to do, let's go back to the documentation. So we have to search for the entry start sub enqueue server, and we have to modify this section. Depending on the installation, you will have a restart program there, and we have to change this to start program. So let's see what we have in our profile. So this is the section start SAP enqueue server, and here we see we have a restart, and we have to change this to start. Save these changes, go back to the documentation. So what we have to do, verify that these two lines are in the sub-instance profile. They have to be added to make the sub-control framework able to provide information to the cluster framework. Yes, okay. For the communication between the cluster and the SAP Substart framework, we have a SUSE cluster connector running or available in the system. And this SUSE cluster connector is required to meet the SAP certification. And now we have to integrate this SUSE cluster connector in the profile of the ASCS and ERS, and therefore we have to implement those two lines. We already prepared this in this example, but we have to uncomment those two lines. So they are here, and we have made a special section for that, SUSE entries for the SUSE cluster connector integration. Okay, now we can save and close the profile, and we have to repeat this for the ERS, if I'm right. Save and close the file. That's what we did. Added the profile for the ERS in the same way as we did it for the ASCS profile. So we have to search for the start enqueue replicator. In that case, we have to change it from restart to start, and we have to uncomment these two lines, and then we have to save and close the file. Okay, that's easy. So we can use here the ERS, and we have the ERS virtual hostname profile. And now we have to look for the start enqueue replicator. It's also restart, we have to change it. And now it's start. And we see the entries for the SUSE cluster connector integration here. So we have to uncomment those two lines and save the file and close them. Perfect. Back to the documentation. Next step, we have to do this as root. So add the user EN2ADM to the Unix group HA client, and we have to do this on all nodes. What we can do here is we can run this with the cluster shell, and it makes the work a little bit easier for us because it's done on all nodes at the same time. I will copy the command and then we go back. So I'm root, and now I will paste in this information here. And now this command, the command user mod, modify the group, or add the group, HA client, modify the group, HA client, and adding the SID ADM to this group is done on all nodes. So we get a return code 0, that's fine. And now we can check if this was really successful. And therefore we have a second command here. Now we grab for HA client in the etc groups, and we will see, okay, now EN2 is member of this group, HA client. So there we have an example how it should look like. It was the same for us. And now we can start the SAP system. To do this, we have to start the service, the substart service, and we will do this on both nodes where the SAP system was running before. So in our case, it was SUSE1 and SUSE2, SUSE1 for ASCS and SUSE2 for ERS. We can use the virtual host names, or if we still remember where the systems are running, we can use the physical host name. So the easiest way is to do this as a SID ADM, and then we use the command start service with the SID. I will copy the command. So on SUSE2, the former ERS host, I will start the service here. And switching to the SID ADM on SUSE1, I will also start the command here using the right instance number. And now go back to the documentation. And now we can check with SAP control. No, we start the system. Okay. On the ASCS host, I have stopped before the whole SAP system with one command. And if the substart server is running on all nodes, I can also start the whole SAP system with one command. And we can check if the SAP system is running on all nodes. And as you can see here, still in the management console, we got an update. The SAP system is green, so the SID is green, the ASCS service is green, and the ERS service is green. And now we will check this on the console too by running the command get system instance list, which is the global command. So as you can see here, the management console already shows us the ERS is green. The get system instance list command is a little bit slower, and it shows still gray. So we have to wait some seconds. Until we get the actual state. And now it's green. Perfect. So we have our ASCS instance number 00 and the ERS 10. Both instances are green. Go back to the management console, and now we should here see in the process list the elapsed time is quite low, so it's a fresh started service, and we have different process ID as before, and the same for the ASCS. The elapsed time is quite low, so it's a fresh started service, and also the process ID is much more higher than before. So, okay, we have mentioned this here. Repeat the global status command as long as all instances become green. And we have to check the status also with the SAP management console. That's what we did. Everything looks fine. Now we have prepared the SAP instance. We have our cluster up and running. We can implement the subsystem into the Pacemaker. Therefore, we will do first a check, a quick test to see all cluster nodes can be communicated together, everything is fine. Then we'll set the cluster maintenance mode. We will prepare a cluster configuration file, and then we will load this cluster configuration file into the cluster. And then we will release the maintenance mode from the cluster and see if the cluster can work and deal with the SAP instance. We can do this from one of the cluster nodes, SUSE 1, 2, 3. And the next steps has to be done as a root user. And first we will do this pre-flight check, so a quick test. Therefore we run the CRM cluster run date command and see if all nodes can communicate together and if the timestamp on all the time is all the same on all nodes. So you can copy the command or you can type it. And so we have to do this as root. I guess I'm logged in twice, so CRM cluster run date. Okay, this command shows me I'm able to communicate to each cluster node. Communication is okay, and the time on all nodes is the same, and that's quite important. So also DNS is working, so the name server, name service server is functional. Go back to the documentation, next page. So what do we have to do? Okay, we have to set the cluster in maintenance mode. I'm not happy with this selecting function. Okay, set the cluster in maintenance mode. CRM status says now cluster is operational, and with the CRM maintenance mode, the output will change. Now we have here resource management is disabled and the cluster will not attempt to start, stop or recover any service. And if we have a resource in the cluster, we will see here, as for our IP address, this resource is now unmanaged. And we should also see this in the HOG console, that the cluster is now in maintenance mode. And yes, we can see it here. We have this tool there, which means cluster is in maintenance mode. And we have this also on the resource and on each of our cluster nodes. Okay, looks consistent. Back to the documentation. As next step, we recommend to prepare your cluster configuration in a small file, and instead of modify the cluster with each line manually, we recommend to use this. You use cluster configuration file, and when you finish the work, you can upload this file into the cluster with one command. Therefore, we have prepared a generic file, and in this generic file we have some placeholders, and these placeholders must be adapted to the situation what we have here. So in that case, we have to modify the placeholder SID with the real SID of the SAP instance. We have an instance number for the ASCS and ERS, which must be changed. The path for the storage where the ASCS and ERS is installed has to be modified. The IP address for the virtual host name and the virtual host name must be adapted in this file. You can do it manually, or you can also use the SAD or this SAD or the substitute command from VI. And important here is if you use the substitute command from VI, don't use a slash as a separator, because we have slashes in the path variable on the path section here. And if you would use a slash as a separator for the substitution command from VI, that won't be work. And therefore we have chosen a star as a separator for the substitute command to make this possible in our case. And the explanation is also here why we have used a star in case of instead of a slash. Next page. So we will name the file as we have recommended here. So instance number HA_txt. And the benefit of that is we can later on run a check what we have provided only for this course. It's not per default there, to see if the prepared file is in a good condition and can upload it to the cluster without any issues. So to make it much more easier to fix the issues before in the cluster configuration instead of later on when the cluster goes crazy. Okay, so we will copy this generic file. Let's do this here. So we copy from a shared system, the course number, the generic file as to a SID specific file. And we can open now this file. So as you can see here, we have these placeholders, SID, instance number, ASCS path, the directory. So we have this information multiple times, and therefore we recommend to use SAD or the substitute command of VI to modify all these changes here. I have prepared already such a file. I guess it's there. No, it's on SUSE3. So here I already have prepared such a file. And I will copy over this to the name what we have recommended, and now we can have a look into this file, and you see we have now changed the instance number, the SID, the instance number. We have a path here where the ASCS is installed. We have an IP address entry there. We have the virtual host name mentioned here, as you can see here in the whole profile. So everything is prepared. Now we can run the check command, and the check command was here, submint cluster check. Okay, our prepared file looks okay, and now we can proceed, and everything looks okay. Yes, conclusion. So the configuration includes 3 resources of each SAP instance. We have a file system, IP address, and subinstance. Okay, that's what I have to mention. And we have 2 groups, a bundle of resources. We set the co-location constraints, and okay, then we can load the configuration. Okay, let's go back and look in the file again. So what we have here? We have a primitive for the file system resource for the ASCS. we have the same primitive for the file system resource for the ERS. Then we have an SAP instance, a cluster resource called primitive RCIP for the ASCS. The same resource IP for the ERS. Then we have an resource for the subsystem, for the sub-instance for the ASCS. And we have an sub-instance for the ERS. We built two groups. One group for the ASCS, and this group consists of three resources: the IP address, the file system, and the SAP instance himself. The direction in this group gives the direction for starting and stopping the resources in the right way. We have this similar group for the ERS. It also consists of the IP address, of the file system, and of the SAP system himself. Then we have a co-location. That means ASCS and ERS should not run on the same host. To have the high availability function of the central services of the SAP systems realized, we have to run the ASCS on one host and the ERS on another host. And this co-location constraint here takes care for that, as long as it is possible. Therefore, we have this minus 5000 here and not minus infinity. That means, if possible, run this resource, spread it over multiple nodes. If not, they can run on the same host. Okay, and here we have this, we have an additional order constraint, which says ASCS must be started first and then ERS. Okay, go back to the documentation. Next step is loading the configuration into the cluster. So it doesn't matter from which cluster node we are doing this. We can do this from every node where we have the file cm configure load update and the file name en2 hatxt. So as you can see, we did not get any failures back here, and in the cluster HOL console now we see a group which is called SID ASCS and SID ERS. And here also already see, okay, ASCS is running on SUSE 1 and ERS is running on SUSE 2. But the cluster will not take care of these services up to now, as long as he is in maintenance mode. And that's what we are changing now. So if all work well, you should get a prompt back with no additional information. That's what we got. If you get additional message here, solve the issue before you continue. Okay, that's not necessary in our case because everything works well. So now we release the cluster maintenance mode. So I guess I did this on SUSE 1. So this was the maintenance mode, and I changed it from true to false now. And if we look on the right side, we will see this symbol will go away. Very good. So the cluster is now in operation mode. Let me check what we have to do next. Yes, we can check the SAP instance from the cluster perspective with the command on the terminal window, and We can also check the SAP system in the management console, but let us start with the terminal window first. Okay, what we can see there is now we have still 3 nodes, but now we have 7 resources configured. One of them is the virtual IP address, and we have 2 groups, a resource group for the ASCS with the IP address, the file system, and the SAP instance. And we have a resource group for the ERS with the IP address, file system, and the SAP instance. And here we can see where the services are running. So ASCS is running on SUSE 1 and ERS is running on SUSE 2. Okay, with Control C we can go back to the console and leave the crm1 command. And now we can also do here a refresh to see if something has changed. Yes, now we have this high availability function here. So we can open it. And now we are able to move over this SAP instance between all 3 cluster nodes. So with the SAP SUSE cluster connector integration, we are able to use the SAP management console or the SAP control command to switch or to move a resource from one node to the other node. And we should also see this on the ERS host if we do a refresh. And now on the ERS we have the same information, high availability section here. We can open this pull down menu and we can see the ERS is running currently on node SUSE 2. And we can open this menu here and we can decide on which node we would like to fail over this resource. So, as I mentioned, the Java console is sometimes a little bit slow. It's also helpful if you close the management console and open it again, log in with the SID-ADM credentials, and then mostly the informations are visible. Okay, what's next? Okay, now we come to testing the cluster. Okay, let's start with testing the cluster and see if the SAP instance, what we have integrated in the cluster, is working very well, and the cluster takes care for the SAP instances, that they are up and running, and the cluster works in the right way, that we did not lose enqueue logs from the ASCS, and that the services are started and stopped in the right way, and to see the interaction between the SAP Substar framework and the cluster tools, if they are working properly together, where we have the SAP SUSE cluster connector in between to make this communication possible. Okay, so testing the cluster is very important. When you have set up a fresh cluster, it's always recommended to do some tests. We have documented this in our best practices, and for this hands-on, we have chosen 3 simple tests here. And first of all, we will make this test a little bit much more realistic, and therefore we will generate some enqueue logs in the ASCS enqueue log table, and the ASCS will replicate this information to the ERS, so that if something happens with the ASCS service, the instance goes down or has to be restarted, that we have the chance to get back the enqueue logs to the ASCS. And yeah, to do this, we have a script prepared, and we have a shortcut here on the desktop. I will start this script to generate the logs. And now we can verify if we have such logs in the SAP, in the ASCS instance. And therefore we will use the sub-management console, click on the SIT ASCS enqueue logs. There we are, the SIT ASCS enqueue logs. And yes, we have now 10 enqueue logs there. So that looks good. For the first test, we will manually migrate the ASCS instance and see if our HA tools are working properly. And then we will also use the SAP tools to move the ASCS between nodes, and we will simulate a node failure. Therefore, we have prepared a table here where we can put in the information before we do the test and after the test. And for the overview, we have here 3 tests. Test 1A, 1B, and 1C. Test 1A is moving ASCS with cluster tools. Test 1B is with subcontrol, and test 3 will be switch of a node. We have to document the ASCS status, where it is running, and if we have enqueue logs there. So that's what we are doing. So first we will move ASCS with cluster tools and check if the logs are there after the test is finished. Then we will do the same with subcontrol command, and then we will also check the logs, and then we will switch off a node. Okay, let's start with test 1A. First we have to fill out or fill in the line 2 of test 1A. So test 1A, I will go back here. This is the information where the ASCS is running and if we have enqueue logs. So we can use the sub-management console, we can use the terminal window, or we can use HOL. So let me do all of them. So here we have the information ASCS is running on SUSE1. Let's go back to the HOL console. Therefore it's easier to use the status information. There we have the group of the ASCS. We can open the group of the ASCS and we see the group is running on SUSE1, and the group consists or contains of the file system IP address and the sub instance, and all of them are running on SUSE1. So that means we can note down this information in the table. So that's a little bit difficult here in the PDF. Therefore we have prepared a text file and make this visible here in the browser too. So I will now modify the text file and document the information that ASCS is running on SUSE1 and we have enqueue logs. So I will do this here. It's called test file. So ASCS is running on SUSE1 and we have enqueue logs. Going back, refresh. Now we have the information noted, and we can go to the test. So the test is described here. So we have to go to SUSE1 and as next. Okay. In that case, it's better to have 2 windows, 2 terminal windows running. In one terminal window, we can follow the procedure with the crm-mon command. It's a live monitoring tool from the terminal. And on the second terminal, we will run this crm resource move command. So let me prepare this. I'm using here SUSE1, and On SUSE2, I will run the crm1 command to see what happened. So now we have here ASCS is running on SUSE1, the whole group, and we will trigger the resource move command on SUSE1. I copy the command, go back. So, and after I have entered the command, I will switch to this second tab where the live monitor of the cluster is prepared. So now we can see the resource is stopped on SUSE1, and starting with the IP address and file system on SUSE3, then the SAP's instance is also started on SUSE3. As you can see, we don't have any failures here, so the command does not generate an issue there, and now we can see the ASCS is running on SUSE3. Back to the documentation. So, wait until ASCS has been migrated to a free host. ASCS is now running on SUSE3, and nothing was running on SUSE3 before. And check the enqueue logs using the sub-management console and fill out the table. Okay, management console, we do a refresh because ASCS is now on a different node. Okay, management console has recognized this. Now we see the information SUSE3 is the active node for the ASCS, and our enqueue logs are still there. Let's fill out our documentation. So ASCS moved to SUSE3, and we still have our enqueue logs. Do a refresh here. Okay, so ASCS moved from SUSE1 to SUSE3, and we have our enqueue logs. Nothing got lost. Okay, what we have to do is taking care that no ban rules are in the cluster for the next tests, and we have to clean up the cluster for that. Because as you can see here, our action has generated constraint into the cluster, and we have to release this. So now this migration constraint is gone, and we can see here everything is as expected. Great. Next test. Okay, conclusion. After a resource migration with Pacemaker tools, all enqueue logs are still there, and during the resource transition of a subsystem is shortly unavailable. Okay, if the ASCS is stopped on the first node and started on the second node, during this time the SAP system is not accessible, but after the ASCS is started and the enqueue logs are restored from the ERS, the system is fully operational and we don't have any data loss. Next test. Okay, for the second test, we have to fill out the second line, test 1b. Now we have to document the information where the ASCS is running. We remember ASCS is running on SUSE3, and enqueue logs are still there. Let me note down this information first. So here We have enqueue logs and ASCS is running on SUSE 3. Update the information. Okay, what we have to do, we will manually moving the ASCS with subcontrol. So we will have a terminal window on the ASCS host. Then we will move with subcontrol the ASCS to a node somewhere in the cluster. So we will not mention a dedicated node, and the cluster will decide which cluster node would be the best node for moving the resource to this node. And we will run the crmmon command to monitor the action during this procedure. So I will copy this command here. And then we have to connect to the virtual hostname of the ASCS. And we can do this here. So here we will start the cluster monitoring. And here we will connect to the SAP EN2 AS, the virtual hostname of the SAP instance. As you can see, we switched from SUSE 1 to SUSE 3. We will change to the SID-ADM environment, and we will run the subcontrol command with the instance number of the ASCS and the function HA failure to node. And we don't give a node name, so the cluster will decide which node would be the best for this action. After I have entered here the command, I will switch to the cluster view on the terminal window to see what happened there. So as you can see here, it's a stopping procedure and not a failure. And he moved the resources from SUSE 3 to SUSE 1. First, he will assign the IP address in the file system, and then he will start the SAP instance. Okay, now as the ASCS instance has started in SUSE 1, we see it here in the HOL console too. And when I open this, you can see here this small sign. This is the location constraint which is added to the resource and which we have to clean up when we do such a manual movement of a resource. Otherwise, the cluster will not be able to bring back this resource again on this node for a certain amount of time. So, okay, we now see the ASCS is moved from SUSE 1 to SUSE 3. We can already document this here. And now we have to check the enqueue logs. What's happened with that? Therefore, we go back to the management console. First, we check the status. Okay, it's still the old information, so we'd have to do a refresh. Now, the active node is SUSE 1, and our enqueue logs are still there. You can also see in the process list that we have a very fresh elapsed time here, so it's a quite new started process with a new process ID, but we still see the enqueue logs. That means the recovery process from the ERS back to the ASCS of the enqueue logs has worked properly. Okay, so that's what we did. And now we have checked the management console. We fill out the table with the information, and yes, we have our enqueue logs. Store this information and refresh here. Great. Very, very good. And as mentioned before, we have to clear this location constraint, which was added during our manual movement. And if you take care for this symbol here, you will see this information is released. So I will do this here. CM resource clear for the ASCS. And if I open the ASCS again, you see the ban rule is gone. Okay, let me start the cluster monitor again. And let's go to the next test. If we have finished this, yeah. So conclusion, you have seen we can migrate a resource as SID-ADM with the subcontrol command, and we don't lose our enqueue logs. So this gives the SAP administrator the possibility to move a resource from one node to the other node. This will also happen for the ERS. If there are some maintenance work which has to be done on the node, and the SAP administrator has to make this node free with all SAP services, he can do this. If the SUSE cluster connector is integrated and your Pacemaker is running on top of your SAP system, you have the chance and the possibility as SID-ADM to interact with the cluster and move resources from one node to another node. Last test for this is now the automatic failover of the ASCS resource if the node has a failure, and therefore we will switch off the node. To monitor the whole process, it's quite good to log on to the ERS, and we can do this with the virtual hostname, or if we know where the ERS is running, we can use the physical hostname. So let's do it like this. We will connect to the virtual hostname. Okay. It's the same as we have done before. So CRM 1-RFN or RF. So you see ASCS is running on SUSE 1 and ERS is on SUSE 2. So we go to SUSE 1, and now we run this command, which will do immediately shutdown of the node or switch off the node. And after I've entered the command, I will switch to the secondary tab where we can monitor the cluster. And we can also see here the cluster behavior in the HOL console. So, okay, now it will look a little bit different compared to the first two tests. So now we see SUSE 1 is unclean. Unclean means the resource is not stopped or moved with as an expected behavior. So now the resource is failed because the whole node is offline. And the cluster has started the ASCS on a free host, as he has the chance to do this. And now, yeah, everything is up and running. So our command triggers a reboot of the node. So the node is coming back. He's joining the cluster, and he is now back again in the cluster, he's available and able to drive resources if necessary. Okay, let's check here. So the virtual IP address of our cluster view has also changed because it was running on SUSE 1 and it's now running on SUSE 2. So we have to do a refresh here. Log in again. And now we see ASCS is running on SUSE 3. So compared to the first test before, we don't have a ban rule here on the sub-instance because this was not an expected behavior with a command. This was an unexpected movement of the ASCS resource. Okay. Let's check. Oh, did I forgot to fill out the table? Yes. Oh, my fault. So, but we still have the information here from the last test. Let me fix that. This. So we had enqueue logs from our last test. No. So, and it was ASCS was running on SUSE 1, and now we have to check. ASCS is running on SUSE 3. There we are. And what's about our enqueue logs? So we have to see the enqueue logs. So management console has still the old information, so we can try to use this procedure, or we have to do a refresh. So fresh installed, fresh running processes running on SUSE 3. So we are aligned with this HOL console, and we still have our enqueue logs. So we can make the cross here. Back to our documentation, refresh. Okay, so we see we don't have lost our enqueue logs, and as mentioned before, during the transition of the ASCS from one node to the other node, the SAP system is shortly unavailable. Now we have a second test, and with the second test we will do maintenance, or set a resource in maintenance mode with the subcontrol command. So as a SID ADM, we can set a dedicated resource or all SAP instances of one SID into a maintenance mode, and we don't need root access for that. So we can communicate with the cluster with a cluster resource as a SID ADM. So we have a second table for that. We will first using the maintenance functionality, and then we will start and stop an SAP resource with the subcontrol command and see what the cluster is doing with that. Okay, let's use the second table here, cluster maintenance as SID ADM. To collect the information, we can still use the HOL console, the SAP management console, or our terminal window with the CRM command. Okay, first test. We have to fill out the first line of the test 2A, and what information we need. we need the status of the ASCS, and the status of the ASCS, it's started. It doesn't matter where it is, we need the information of the behavior. Okay. So in addition, it's not documented there, but we still have our enqueue logs. And we can also see here the green status information, so it's running. But the cluster information says started, not running. And we use this one for the test. Okay, so it's recommended to have 2 terminals. In one terminal, we will use the CRM command to monitor the resources during the test. And on the second terminal, we will do as a SID ADM the maintenance work. So we copy this, and then we will go to the ASCS. So SSH EN2 ADM at SAP EN2 AS. So we are now on SUSE 3. It's the same here. So our ASCS resource is running on SUSE 3. And I already have started the cluster monitoring tool on a dedicated host, on a different host. It's a SUSE 2. No, where it is? It's SUSE 2. So fine. And now back to the information, what we have to take care for. Before the test, the ASCS is started. So we have to monitor the ASCS during the test and after the test. So that's what we have to look for. So I will set the SAP instance ASCS in maintenance mode, and after that I will switch to the second tab where we can monitor this. So enter this. So now we can see it's started and unmanaged. And as I have chosen the global command for the maintenance mode with subcontrol, we can see the ERS is also went to the unmanaged mode. So let's document this. Okay, during the test, ASCS is now started and unmanaged. Started and unmanaged. Refresh. And to release the maintenance mode, so okay, check the cluster resource in the first terminal and note down the result. That's what we have done. And now we release the maintenance mode with a 0. Going back. So changing the 0 by 1. And check the status on the second tab. And we can see now maintenance mode for the SAP ASCS and ERS resource is changed from unmanaged to normal operation. So we can note this down here. Okay. And update the information here. Okay, now we can see ASCS resource was set to unmanaged during the test, and after we have released the maintenance mode as set ADM, the cluster is back in the normal operation and takes care for the ASCS instance. Check the enqueue logs, that's what we can do. But we don't have started and stopped the ASCS, so there should nothing be happen with the enqueue logs. And as you can see, they are still there. So the procedure shows you that it's possible to set the cluster resource and maintenance mode as city ADM. And as I mentioned before, the example here shows is the global command to set the resource and set resources in maintenance mode. If you add an additional space and a 1 and additional space and a 0, you can switch dedicated resources depending on the instance number into maintenance mode and release them. Okay, second test. In this combination is starting and stopping an instance as SID-ADM. So we will always monitor this situation with the cluster CLI command, crm1 on a host which is part of the cluster, and we will do a subcontrol stop, and then we will note down the information, and then we will start the ASCS again. Let's go there. So first of all, we have to document where the ASCS is running. No, not where the ASCS is running. So we have to document the status. So status is green, so that means started. We can see it here. Started ASCS, and we will document this here. So next line is the information during the test. So we will monitor the information here on this tab, and here we are on the host where the ASCS is running, and the command was stop. This will only stop the ASCS and not the whole SAP system. So let me do this. So control dash mr instance number stop. So when I hit enter, I will immediately move to the second tab where we can monitor the procedure with the cluster tools. So now we can see the instance is stopped and the resource became the additional information disabled. So that means the cluster has recognized the stop of this service was expected and was done with a SAP command, and the cluster will accept this information and will not try to restart this SAP instance. Because we have the SUSECON cluster connector here in between the cluster and the SAP Substart framework. Okay, let's document this information. So ASCS during test, it is stopped. Oh, it is stopped disabled. That fits best. Save this information. Okay. Next step. So we have subcontrol, function stop, that's what we did. Check the cluster resource in the first terminal and note down the result, that's what we have done. Wait until ASCS is completely down. So we can also see in the management console it's gray and ERS is still running. And then we have to start the ASCS again. Let's go back. Use the subcontrol command to start the system, and then I will switch to the next tab where we monitor the cluster resources. So you see the disable status as disable is released, and now cluster recognizes the SAP system has started or will start it. And when the start process is finished, we will see here started instead of starting. Okay. Now the cluster information is updated, the resource is started. We can also check here with the get process list if we have it here. Get process list. And as we can see, ASCS is green, the message server and the enqueue server, and the elapsed time is very, very short, and the new PID. Okay. After the test, ASCS started. We don't have a failure state. And store this information. What we did a start, and now we have to clean up the resources. But first I will refresh here our documented behaviors. So as you recognize, ASCS initially was started, then we stopped it. The cluster was recognizing this and say it stopped and disabled. So it will do nothing on the ASCS instance. And after the test and after we have started the ASCS with the subcontrol command, the disable status is gone and the ASCS is back in start mode. What we can do, we can also check the enqueue logs, and we do a refresh for safety. And what we can see is there was no switch over from the node where the ASCS is running, or was running when we have stopped it, and started is it starts and stops on the same node. So there was no move from one node to the other node, so no takeover happened. And we still have our enqueue logs. Okay, so let me clean up the system that we are prepared for the next tests. SUSE1. And the same for ERS. And check. Okay, everything is fine. No issues there. No problems reported. Check the enqueue log table, we already did. Okay, the summary. So the in-place resource of an SAP resource have been proceeded correctly. So the SAP instance should not fail over to another node. So as I mentioned, it was on SUSE 3 and we were able to start it on the same host. And the cluster does not interact with the in the stop procedure, so he will recognize this information was an expected behavior. And we do not see any failed state in the cluster live view. So for the first test, we can say with ENSA2, ASCS can move between three hosts into a cluster, and he will retrieve the enqueue logs from the ERS over the network. That's working as expected. With subcontrol and the SUSE cluster connector, the cluster is aware of starting and stopping of SAP workloads and does not interact in such a case. That's very important for a rolling kernel switch where the SAP instances starting and stopping during this procedure to get and activate in your kernel. With subcontrol and the latest SUSE cluster connector, we have the possibility as SIT-ADM to set cluster resource in maintenance mode. And the general conclusion is with SUSE Linux Enterprise Server for SAP application and the HA implementation will make your administrative life a little bit easier. So the SUSE Linux Enterprise Server for SAP application helps you to maintain such an HA environment on a very easy way. This was our hands-on training. I hope I could make my point and show you the differences between the HA cluster integration of the SAP central instances ASCS and ERS with the SUSE cluster connector and without SUSE cluster connector. So with the SUSE Linux Enterprise Server for SAP application and the SUSE cluster connector integration, your operating and maintenance task of your SAP system in such an HA controlled environment is much more easier because the SUSE cluster connector takes care to inform the Pacemaker cluster that start and stop or any other SAP maintenance tasks or operating tasks are an expected behavior and the cluster will not interact in such a situation. And the SUSE cluster connector is taking care of setting the right statements in the cluster, like a resource is disabled, or you can use the maintenance functionalities with subcontrol and set a resource dedicated in the maintenance mode. Without the SUSE cluster connector, only with the SAP database cluster integration, you won't have such functionalities, and you have to take care to set a cluster in maintenance. If you would like to start and stop or do some maintenance on the SAP system to avoid situations which could break your SAP system. Thank you for your patience and see you soon. Bye bye.